This aeroplane. Earlier, the HF-24, the HAD-16, the aeroplanes were designed there. Then we have the Rotary Wing Research and Design Center, RWR and DC. That's where our ALH, Advanced Light Helicopter, is being designed and produced. Then we have Engine Design Center, where quite a bit of engines are being developed, but it's an extremely tough thing to design high-speed turbine engines, and we have not made, in my view, we have not made any great strides as much as we could do in the aeroplane side. So generally, a lot of engines are imported. As you know, the Tejas aeroplane G404 engine or the advanced light helicopter Turbomeca engine, they are all imported and subsequently license produced. Then we have Strategic Defense Electronics Research and Design Center in Hyderabad, where avionics, avionics and the electronics of which goes into the airplane are developed there. Then we have a R&D center and aircraft upgrade at Kanpur. We have an R&D center, aerospace systems in Bangalore. Then we have gas turbine research. All these powerful engine gas turbines, we are also trying to convert them into industrial gas turbines, especially those which have completed their life on the airplanes. So that is another big business center. Then we have a laboratory. Again, a laboratory is a very important laboratory. Also, is a research and design center. So this is our establishment. I think this is it's a bit of a repetition here. A little bit more clearly, I wish I had read these slides, which are a little bit more clear. I put the helicopter complex here, which has been a little bit reorganized to put all helicopter business under this heading. So with that little bit introduction to HAL, I'll get into what HAL is basically structurally consists of, as I said, manufacturing complexes, the design complexes, maintenance and overall centers, some in complexes and some in the customer bases. Then we have the helicopter complex and the customer bases also, we support them very well because a large number of airplanes have to fly day to day and they have to be maintained very, very well with the least number of accidents, I would say. Then they have to be overhauled regularly back in the manufacturing center. Then we also have liaison centers all over the country, all over the world to handle our business from abroad. Then I'll just come to once again the helicopter complex where we have the Rotary Wing Design Center. This basically this helicopter complex earlier produced two types of helicopters called the French Llama, christened as the Cheetah helicopter, Alouettes, Chetak helicopters, used for about 2 decades. Then 2 to 3 decades. In 75, we conceived designing our own advanced light helicopter, ALH. Initially, we had a collaboration with the Eurocopter of France for a couple of years. Subsequently, we had a major change in design, so we had to choose another collaborator, Eurocopter Deutsch, the Germans, who were with us for 10 years to handhold our design team and a prototype builder team. A team of about 50 odd engineers was stationed with us. We paid them quite handsomely, I would say. But to learn our first technology build of a new helicopter, we had to do that. This was from, as you see here, 86 to 95. And this is a very, very prestigious concept of building our own helicopter. Incidentally, I may say that we are the fifth and the sixth country to totally build entirely a helicopter under one roof. Apart from Russians, the Americans, the French, and the Germans, we are the fifth country to try to build our own helicopter entirely. Although Japanese and Chinese have built a couple of them, but they have taken a lot of help from They have done it jointly with other people. They have not done the major components on their own. They have done simple things, easy things, maybe commercially viable things. So I think it's a feather in our cap that we considered ALH design, and timely we have done this during the mid 80s, and in 2020 today we are in a very powerful situation. So our design bureau RWRTC consists of the prototype development shop. I just mixed up a little things. Design bureau has a design department which produces all the design drawings of components. Then all the components are being fabricated in the prototype development shop. They are being assembled. Then they are put into intensive test, component-wise, assembly-wise, unit-wise, ultimately as a total vehicle. So as a ground vehicle. So all these activities are the part of this prototype design bureau, and we have similar design bureau for the Tejas project, a different type of concept for other design complexes like Hyderabad division or whatever it is. They all have to have a prototype development, a testing shop, an assembly shop, things like that. And all these machines, when they get fitted up, they are subjected to flight test in Bangalore. Generally, Bangalore has a very good telemetry station. They track the aircraft in real time, gather the data in real time. They give and they do a lot of testing on ground. Then give the instructions back to the pilot to do this test, do the test, and then do a very optimum amount of flying. Then we have a flyers deputed from the our services, Air Force, Navy, the regular flyers, a good number of flyers. They are with us. They do all the flying for us. Prototype machines flying. Then we have certification agencies from the government side. They're called the engineering certification and the manufacturing certification. They all do the quality control in terms of manufactured components, quality control, as Balakrishna sir were telling, and then and the engineering side to check with the engineering standards. Basically, we have FAR standards for civil certification, military standards for military certification, and they all prescribe what is required in terms of achieving the design parameters. Particularly, I think what is important in case of aircraft, unlike ground equipment, is the flight safety. When you are in air, you have got to make sure that you are safe. That is one reason we had to have two twin engines. If one engine failed, the aircraft was supposed to come down safely. But if it is a penalty to have a second engine, but it's a compromise between having multiple engines and having to achieve a safety. So also is a number of hydraulic pumps, a number of hydraulic actuators, number of course, controls. The pilot, co-pilot is a duplicated sitting system. It has to be duplicated because they share the job, they share the cockpit resources. Then the number of systems are duplicated to ensure that there is sufficient safety and in terms of backup supports. So that is where all the certification agencies, look up all our design and drawing right in the early first day of the design. Then we had a collaboration team. All this tough thing, if you are doing it the first time, it is very likely that we will have a lot of failures, and it has been experienced. And it is typical to start an initial design with the collaborating team, and we had the collaborators hand-holding us for the first 5 years when we did the flight of the first ground vehicle, and then subsequently, seventh year, we did the flight of the first flight test vehicle. We flew it. Then all along, we had several problems, a large number of problems, teething problems, hiccup problems. We had to get over them with the help of these people. So coming to, I think I have been doing a lot of talking. Let's see some actions here. This is the advanced light helicopter which was designed. I start with the top. Rotors are made out of carbon composites, not at all, no metal at all. The earlier Cheetah Celtic helicopters were made of aluminum alloy materials of these 50s and 60s, then when the composite materials were not available for commercial use. And now that composite materials, basically this araldite and glass fiber, carbon fiber, where you can put the fibers in any direction. You can lay them, you can weave them, you can put araldites, you can layer them one top the other, you can build the thickness, you can build the radius, you can basically build a structure synthetically, I would say, to whatever properties that you need. So that is the beauty of this composites, and that is what we have used, carbon composites for the rotor. And this rotor, unique feature of that is supposed to be that it is a hingeless rotor. It doesn't have an articulation here in terms of bearing. So therefore, it's supposed to be a very powerful rotor in terms of its power capability. Then here is a very important hub. Typical helicopters have a solid shaft and the control rods which give the tilt to the rotor blades. They are all visible outside and they are all rotating along the shaft outside of it. But I think for some reason we have first time ever anywhere in the world we have conceived this idea to put all the control rods inside a hollow shrouded hub shaft. That's a wonderful design we have got, and the shaft there is it's a hollow shaft. Control rods are running inside. Then there is an engine on either side. There's a gearbox in the middle. All this thing entirely was designed and developed in our Bangalore design complex in about 5 to 7 years. Then we have this is called the fuselage, the pilot cabin, the cockpit electronics panels here, the passengers sitting area here. There is a clamshell door through which you can take vehicles in and out, some small vehicles in and out. People, the army people to go in and out. There's a tail boom which goes over there, and then there's the main rotor which produces a huge torque is to be countered with this long arm and tail rotor torque at the back. Then the army people uses skids to land on any slopy lands, marshy lands, mountains, and some things like that. So they typically use army and air force people use skids. Then inside this is the hydraulic controls, duplicated, as I said, powerful hydraulic controls for operating rotor controlling actions. So these are the horizontal and vertical stabilizers which manage to stabilize the aircraft. The thing that I want to tell you is that this helicopter is supposed to be hanging with a single wire on top here. So it is like I would compare this to a single wheel bicycle, but not a bicycle. It's a single wheel monocycle which is hanging on top. So you have to balance the center of gravity of this vehicle very carefully within about 50 millimeter, 50 centimeters here. In this region, you have to manage the center of gravity. Even then, if it is perfectly in the center gravity center, you have a balanced helicopter. But if it is on the front, it tilts forward. It's back. If it tilts back, and that is what the pilot sitting there. He'll be watching outside his window, outside the window, and just like we do a bicycle balancing, these pilots do the balancing. And it's a very interesting thing. It's supposed to be an unstable machine. And that is where I had a lot of interesting experience of flying inside some of these helicopters to learn what is this balancing and unbalancing story about. And then I learned what is the stabilization issue. Then I had to do automatic stabilization basically. Balakrishna sir would appreciate this, being closed loop control and stabilization of a machine. He has dealt with very powerful machines on ground, and this is another powerful machine in the air, which you have to stabilize. And so all this makes it a very complex design issue to fly a vehicle in the air. To fly a vehicle in the air, to make a vehicle on ground and air is a 10 times complexity in terms of design, in terms of cost. More than anything is cost. everything is 10 times the cost. So I'll just move to the next slide. I don't know, I'm running out of time. This is a naval helicopter, almost the same technologies incorporated, except that the front and rear wheels, which are required to push the aircraft into ship hangars and typically move over the ship and land back on the ship and anchor it into the hangars. For that reason, they need this. But once it is in the air and to reduce the drag, the wheels have to be retracted inside. So you need additional hydraulics to take the wheels back inside in this area and then close it. Other than that, the naval people also look for folding these blades. They can't push a helicopter with 13 meters. It's supposed to be 13 meters or 25 meter, 27 meter rotor. They cannot go into a hangar and hit each other and things like that. They want this blade to be folded. It's a very, very tricky issue. Manually, we are able to fold easily, but there are helicopters where it is done hydraulically. In the sense, hydraulically lift this lift one of these pins hinges here and push the rotor back and things like that. So, having shown this, I'll just briefly show you the kind of shrouded hub shaft, central shaft which we made. These are the black ones are looking the carbon hub plates which are holding the main blades, and then the controls are running inside. Here the big gearbox, which is I believe it is partly titanium material for to withstand the kind of temperatures and strength. And these you can see if you can watch it here. These are the engines which take the shaft into the from the sides, and the vertical shaft comes out flying at rotating at about 300 rpm. This is the I believe this is the Kevlar and other material composite non-metallic structure for the fuselage for the cockpit and the cabin of it. And here you can see the attachment of the rotors. This is a very, very special rotor uh, which we designed with, of course, with a lot of some expertise from our collaborator. So we have a main rotor hub and the fuselage. The assembly, typical assembly, uh, very, very compact assembly on top. And what the pilot has in front of him is the panel. Initially, when we started this system in 1985, until about 1995, we flew most of the instruments were mechanical instruments, typical of those days technology, and subsequently we converted all those instruments into what is called as electronic display. So through a software, you can select whatever instrument you want. If you want flight instruments, you can see them. You can see engine instruments. This is the co-pilot who is watching the instruments. If he wants to see a battery condition, he can call that instrument. If he wants to do navigation, he wants to see the map here, the Google map or world map or flying map, he can see that here. So is an electronic software controlled display called this is use a special terminology called glass cockpit. The cockpit made out of glass rather than the conventional mechanical instruments. However, you still need emergency for when this packs up for whatever reason, if the electronics fails, you still need mechanical reliable instruments. Some of those emergency ones, especially the rate of climb, the forward airspeed, the heading. Some of those instruments are essentially required. They still work on some special batteries, inbuilt batteries, and they are still required in spite of these reliable electronic display. This is the warning panels and other avionics and control panels, communication, navigation, weapons, and all kinds of things which are there on the pedestal between the pilot and co-pilot. So I'll get into the kind of work which we did as helicopter designers. We had to design the rotors, as I said, the fuselage, the engine, and the engine was a bought out item, but we had to design the transmission gearbox system. We had to design the landing gear wheels going inside in extraction and in inside and out. Then we had As an electrical engineer, I did design of several electrical power systems, all the generating system, the instrumentation of it, then the controls. As an electrical engineer, I enjoyed doing this control system design for the helicopters or the controls. Then my friends did the hydraulics engineering for this thing is a very important power, basically the power arm of the helicopter. Then cockpit environment, then the entire avionics suits, which were taken from our accessories complexes from Lucknow and Hyderabad. And we had a system called a flight control system is a hydraulic mechanical, but interface to that hydraulic mechanical system with an electrical small actuator, which goes and operates the hydraulic actuator. That electrical actuator is supposed to be a limited authority of a 5 to 10% kind of thing. It is controlled from a computer, and then all kinds of sensors on the onboard, the gyro instrument, the stabilization instruments, the accelerometer, the rate gyros, and many of those things are brought into a computer, and computation is made as to how to stabilize it. Once the aircraft is stabilized, when we do an autopiloting operation. T is missing here. Autopilot operation is to fly the machine at various functionalities automatically, and the pilot is very happy to let that be done by the computer, and then he's off to do his assigned jobs of in sitting in the cockpit. So the technologies which went into this helicopter, I think it's a bit of a repetition. Bear with me. Lightweight materials were used for rotor and fuselage, gearbox. I think we did a very good crash proofing. We had to have specifications, meet the specifications of saving the pilot in times of helicopter coming and hitting the ground. So we designed a system which will absorb all the shock in the seat. So the seat had a shock absorber system. Then the gears, the wheel, the structure, all of them will collapse, but the pilot is to be saved from severe damage or severe injury. And that's what was done. And then we had to do as I explained, that we had to tune the rotors for building in specific dynamic properties in terms of flap frequencies, the lead lag frequencies, the torsional frequencies of the blade. These are three important resonance frequencies which have to be nicely tuned so that the machine runs smoothly. And I explained this router shaft. I'll talk about the tuned vibration isolation system. Rotor controls, hydraulic. I talked about the glass cockpit. I talked about it. Then avionics, I said. To talk about this rotor vibrations, a very interesting thing that the four rotors which we had, all of them, if the aircraft is flying forward, the forward rotor, which is called the leading rotor, experiences its own velocity, air velocity, as well as the forward velocity, whereas the retreating blade, which is going back, experiences the opposite. So the result, the difference in the lift vector between the two rotors in one rotation is almost 40 to 50% of variation in the load, and that causes extremely high vibrations into the body, so it becomes unbearable to sit inside a helicopter cockpit. I see some message here. Annotating. Okay. So as I explained, I did all the electrical closed loop activation control system for the autopilot and automatic flight control system. To explain to you, is the helicopter has got a collective stick onto the at the floor of his seat, then which lifts all the rotors up and down. Therefore, it goes up and down. It's called a collective control. It enables the helicopter to do the hovering. Then he has a stick to move forward and backward, which is supposed to tilt the rotor plane forward or rotor plane backward to go back and forth. rotor plane is tilted left or right to take the helicopter. So helicopter is one which can land anywhere on the ground. It doesn't require a runway. It can land on forest. It can land on ships. It can land on small boats. It can land on anywhere, and therefore buildings. And so that is the advantage of the helicopter. But it is called since it cannot go beyond 300 kilometers per, per hour speed. It's a vulnerable as far as fighter planes are concerned. They call it the sitting duck, but helicopter has got its own role to play in a military. It can fly behind the buildings and trees and then do its own war games. So I think I explained all these functions which are done in a typical automatic flying. You can fly navigation. Once you fix it that long, you can the helicopter will automatically take you from one place to another. You can fly at a particular height, and if you are doing any hovering, and then if you are doing any rescue, if you are picking up somebody from the water, you can do a height hold. You can fly at a constant speed from place to place. You can fly to a constant heading. If you are targeting to go somewhere, then you can do all the rescue operations of pulling up a person from waters. So then there are several of military operations that need to be done automatically, and all those things are done there. And a typical development cycle, I think, is to build a helicopter safe, build the prototypes, ground vehicles, flight vehicles. We built 4 prototypes. In about 6 years' time, we flew the helicopters all over the country. Into deserts area, the Himalayan area, the airships, waters, Visakhapatnam, Goa, Mumbai, Jodhpur, and all kinds of places to make sure that it meets the specifications of the customer. As Dr. Balkrishna was telling, customer specification is sacrosanct. We had to meet them, and they would, unless they put a tick, you don't get your payments and clearances. And then finally, in about 7 years, I think in about 8 to 10 years, we completed all the certification. We call this as a Dhruv helicopter, which is the pole star of the nation. And till now, we have produced the 300 helicopters, and all those veteran designers, about 3 decades, I think they all started retiring one by one, and the next generation of people, including my juniors in the last decade and a half, they have produced variants of this called the light combat helicopter, where they put the pilot and co-pilot one behind the other. A light utility helicopter for to fly in the Himalayan area at 6 kilometers altitude. These are the only 2 helicopters in the world which can fly at 6 kilometer altitude with the kind of power required, with the kind of rarefied atmosphere, and with kind of engine power conceived in these helicopters. And these are the only few machines which we are able to use in Indian context in the Himalayan. I think that is where is our plus point as compared to our adversaries on the eastern side. We also have conceived to build a bigger helicopter. Till now, what we have built is about 5 ton kg class helicopters. It's a leader today in its particular weight class, like the Sikorsky S-76, the Bell 412, the Bell, the as the other the French Dauphin helicopters. It is a leader among all of them, and we have made a very good beginning. And in the next couple of decades, I think we have to be probably the leader. And looks like economically and all that, we are going to be at least the second and third place. It's not easy to win that economic condition, and I think India should do it. And I think all the college students, youngsters, next generation should take it of them. I think I have come to the last slide. I have a set of references here. If we had time, I thought we could run some of these videos, very interesting videos. I have listed here. People can use it. Then I think I have the last slide here. My email ID, my WhatsApp number. Any questions, please shoot them anytime. Not necessarily today, but any other time. It's welcome. And There are a few things I thought I'll.
Professor
Yeah.
Professor Joshi?
Yes, sir.
Shyam
Yes,
Sundar
sir.
sir.
Yeah,
Yes.
I have busted the time. I know 6:30.
Yeah,
Yeah.
no problem. It
No,
was
but
quite
it was
interesting.
interesting. Yes,
Very
sir.
interesting. Professor
Yeah.
Joshi, I will have just one point to make. Right turn.
Sure, sir.
Professor Jagtap Sab is there?
Yes,
Professor
sir. He is there. Yes, sir. He is there.
Yeah,
Yes,
I
I'm
would
there.
left. Sir, Professor Jagtap sir, both
Sir.
are two extremely different topics, but
Yes.
right. They have given very good inputs to us, and I request you to please kindly conclude with your remarks, sir. Please give your remarks, and then you may also moderate if any questions are there. I request you, sir.
Yeah.
Jagtap sir.
Just give me a
Thank you,
second,
sir.
sir.
I have posted two questions, one for
Oh,
each,
Bapre. That's great. It
privately,
shows
of
you,
course.
it,
Yeah.
it, it shows your academic bent of mind at every level, sir. Please,
Yeah,
sir,
please.
Jagtap sir, please.
Yeah. Have speakers seen my questions?
No, I
You
have seen.
you
I
may
should say.
directly ask. I think they may not.
Yeah.
You may directly
To
initiate
whom you have
discussion,
sent,
sir.
I can see one question.
Yeah. First question was for Mr.
Yeah.
Putu. I'll read it out what I wrote there. Thanks a lot for educating on all points. Congratulations on putting patience at the top of the agenda. My feeling is that our youngsters lack very important quality. They want quick results and therefore they probably choose job as a career. What can be done to prepare our students in this regard? Youngsters can learn a lot from your experience.
I will answer to this one, sir. I am ready to explain all my experiences to the youngsters, but
Arupti,
there are many situations can be explained on case-to-case basis. So it will be difficult without knowing the case of the experience. So if it is required, then I can explain to the students directly also whoever is raising the questions.
Okay.
I think will it be sufficient this type answer presently?
Yeah. I mean, what I mean is that when we talk to the youngsters, they are
Yeah,
interested in becoming entrepreneurs. However,
yes,
the initial phase of struggle, some
yes,
don't understand and they don't want to go through that phase, and that
yes,
many of our youngsters do not get into the entrepreneurship or startups. Very few.
yes,
You need to have a very a rich background or something like that to wait for 3 years, which need not.
yes,
So this is where students will require advice, guidance, and it would be nice on behalf of Batu. I would say that if you can interact with the students sometime and take up such questions, most of them are going to ask these questions. How do I
no,
survive for 3 years? What do how do I do this? My family doesn't permit me. There are all kinds of mental
yes,
blocks our students have. So how did you sell through all these points? It's very important.
yes, yes. That's why I written the patience word,
Yes,
because
yes,
at least you require 3 to 4 years to achieve
yes,
something when you
yes.
do a startup.
Mm.
Because out of 100 startups, hardly 2 or 3% they succeed, and rest of them within 2 years, 3 years, they go back to the job.
Yes, yes,
So how to save this and how to increase this percentage? This can
yes.
be done only by
That's
explaining them what they have to
yes.
do and what is the patience required by them.
Hmm.
So I can have a one-to-one interaction with the students if
Oh,
required, and
that
I
would
can
be
explain my difficulties, what I had faced
yes.
during my startup periods. how much time you have to do the job.
Mm.
Maybe sometimes you may require to work more than 24 hours a day.
Yes, yeah,
So
absolutely.
they should be prepared for that.
Yes. The second question I have in this same context is like Harvey Firestone had said once that to start a business, you need an idea. You don't need
Yes.
money. You don't need manpower. If you have the
Yes.
idea, you can make most of your business. Now, how to
Yes.
get these ideas? This is another thing that our youngsters would like to know. I'm not saying
This is
that.
very difficult. Very difficult question. But these ideas has to come from their own thinking.
Yes.
We are not, others cannot give the idea to them.
Sure. Sure. If I have an idea, I will make money out of it. I will not give it to anybody.
Yes. Yes. Why I will give my idea to others?
Yes. Yes. But at the same time, how to fish around the ideas? There's a training which is required for our youngsters.
Yes.
Which does not happen in our
No, I
system.
think we need to, sir, Jagtap sir, I would like to take a small lead from your point,
Sure.
sir.
Sure.
Yeah,
Sure,
I
sir.
think at DBOT through our innovation cell, incubation innovation enterprise cell, and Atmanirbhar Bharat cell, I think combinedly we need to do something about the point you have mentioned, sir.
Yes.
I think it is a great, and Balakrishna Saab, I would be banking on him and some of his friends like Parvati Karzi and who are very close to us in Pune. They are all, and many more are there also. I think we need to have
Yes.
some awareness programs about these things.
Yes.
Some coaching. We will do that, sir.
I am
Definitely.
ready to give it.
Very good.
Yes, sir.
Right, sir.
Very good. Very good. Very good. My other question was to the other distinguished speaker. See, it's a very excellent presentation on the aviation sector. But suppose there is a young engineer
Yeah.
coming out of the university. What are the entrepreneurship opportunities for him in this sector?
Yeah, I have to answer this question. I was about to put this question to myself and then answer it, but I'm glad I'm answering a put forward question, and it's extremely relevant and very important. You see, the amount of flying we did in the 70s and 80s was very little. The cost of flying and air tickets used to be very expensive in those days. And those are the days when aviation was very expensive. But in the last 3 decades, you would have seen that the air tickets the prices have come down heavily. The amount of flying we done is increased much more. We are doing a lot of short hauls between small towns and cities. Karnataka probably had in those days only Bangalore as an airport, but we have half a dozen airports. Similarly, other states. So in future, I think the civil aviation is going to grow in a very, very big way. Helicopters is my domain. I would forecast helicopter flying much more in the next several decades. And it's a huge market. It appears the forecast is said that the civilian market requires 2,000 helicopters or helicopters in the few decades, next decades, and so also the military. And these are only domestic, but I think India is caught up. I would say we should be very happy to say that caught up very well in for the export market and servicing the foreign markets in terms of aviation. And that is how, in our days, we had just about 7 to 10 colleges giving aeronautical engineering degree. I did electrical engineering, but I have to do aeronautical engineering for a PG. But in these days, it's very interesting to see that there are about 30 colleges giving aviation degrees, and a large number of private sectors like Wipro, Infosys, Mahindra. All these people are doing engineering services for aviation companies. They're all outsourcing their work for their own aeroplanes. So nothing to do with the domestic requirements. So a huge amount of export potential is there. But to do design, to do manufacture, there are companies doing manufacture, design, testing, analysis, everything related to aviation. Everything is coming to India for the new generation of youngsters to take it up. And it's a huge opportunity that opening up, as I could realize. And in my own experience, I said, I was telling that after after the old veterans like Professor Dhawan and all those big scientists left, the vacuum is filled up by the next generation of people. And particularly the digital world today has put huge opportunities. And I hope that answers your question.
Yeah. Thank you very much. When the background of my question was also that you may know one Mr. Yadav, right? Who started building small aircraft in Mumbai. Somewhere there. He started like an entrepreneur, a small-time entrepreneur, small-time designer.
Yes.
But to take a lot of government help to progress. So
Yes,
that's
yes.
of worries the youngsters would have.
Yes, yes. That kind of passion they had. And
Yes.
I had to tell something to the new engineers or the students that in the college, the teaching faculty, they also should get trained to the modern approach. Basically, in the industries, what are the requirements are there, that the faculty should also learn before giving the teaching, transferring this data to the students. Because nowadays I had seen in many industries, because I handle most of the steel sectors in India and abroad, where I had seen that the engineers may not be knowing much about the hydraulics as well as the engineering electronics. That means power electronics side. So we have to give more emphasis on these two products, these two things. And it will be really useful to the industries when they approach the industries or when they want to start their own.
yeah, I think you are very much right. Especially the Balakrishna sir has done wonderful work in the industry. Amazing work he has done. He has been a thorough industrialist, and there's a lot of way to interact with the industry and the institutions. It has to be made intensive, particularly now that this type of WhatsApp and communication, fast communication is available. We should make use of it. You see, at the press of button, so many of us are having a meeting and discussion. It's a wonderful opportunity today. And I see that even today, the engineering boys, at the press of a button from the Google, they search for any information, they learn. If they have not learned something in the class, they will immediately learn it. And that is how the world is now moving exponentially. It's going up very exponentially, moving forward.
Yeah. From the audience, are there any questions or
Yes,
any?
sir. There are.
Yeah.
Yes, sir.
Please.
There are a few questions from the YouTube. So one question is for Shyam Sundar sir. He has already explained it up to a extent, but probably this question is from a student, and he wants to know that actually there are very less colleges for aeronautics.
Yeah.
So in that case, how the students from other branches can prepare to go into their career as aeronautical engineer?
Yeah, I think good question. I'm very happy to answer this question because aeronautics is not a separate discipline like mechanical engineering, chemical engineering, or metallurgy, which houses a very powerful avionics knowledge, electronics knowledge, computer knowledge, hardware knowledge, software knowledge, hydraulics knowledge, structural civil engineering, structural design, strength of materials, fluid mechanics. Everything is encompassed in this, and it's a very complex design activity, and any normal graduate can go into a post graduation and then do an aeronautics course in his area of in a narrow branch. If he's an electrical engineer, he can do a lot of electrical related work for the aircraft. Similarly, hydraulics, even a civil engineer, a metallurgical engineer, a mechanical engineer, everyone have a scope in this. And as per the new education policy, I understand one can take multiple exit and multiple entry and come back from industry to institutions, and then do their degree anytime they feel like doing it. They feel they are able to do it, and this type of policy which is coming up, I think the next generation youngsters should make use of this. And aircraft engineering has opening for every other branch of engineering.
Yes, sir. Thank you, sir.
Yeah.
One more question is there for Balakrishna, sir. Sir, again, this question is probably from a student, and he wants to know that what is the difference between a overall entrepreneurship for other products and a technical entrepreneurship. He is confused about this word technical entrepreneurship.
First of all, I can't understand what is meant by only technical entrepreneurship, because even though you are a technical person, just like me, I am purely a technical person. I am not involved in commercial activities, but still we should know about the commercial things and other formalities for that one. You can be very good in technical things. You can develop the things which are not developed by others. We can do the marketing on its own, because there is no need of separate marketing department for that one when you are a technical person, because the marketing is done, mouth to mouth publicity is done automatically by the customers themselves. So this is basically technical entrepreneurship as per me. So if he wants further knowledge on that one, then he can directly interact with me. I can explain
Yes, sir.
what
Sure,
are
sir.
the
Sure.
real things required in that.
Okay, sir. One more question is to you again.
Yes, sir.
The question is from one of the faculty from Satara, and they want to know that what exactly is a service entrepreneurship in service industry, and is it easier to start with the entrepreneurship as a service industry than a product?
Service industry. Yeah. See, there are many entrepreneurs who do only services, but it has got lot of limitations, because service means either you have to repair the existing systems whenever they go faulty, or give them the technical services if they require it. So 99% there is a limitation on that one, because unless the customer requires you, you cannot go there and do the services. So this is the basic issue in that service entrepreneurship.
Okay, thank you, sir. We have
Yeah.
one more question from Santosh Ingole. He wants to ask where India stands in unmanned aerial vehicles.
Unmanned aerial vehicle, I think this is emerging technology basically. In fact, people say that future wars will not be fought on the air, but either it will be fought on the space, or it will be fought only by robotic driven airplanes. So that's what is unmanned aerial vehicle, is a robot driven fighter plane going and delivering the weapons, rockets or missiles or whatever. This is going to be the I think the story in the next decades. I think people have to get geared for this. Although human machine in a fighter plane has a very big role, because he's taking decisions in the sitting in the cockpit and then looking at the outside world and looking at his data on the radar or on his information systems, He takes certain decisions, and that is where some critical wars can win. But I believe the unmanned aerial vehicle is going to be a future war, and India is gearing up very well. There's a huge amount of projections made for making them, developing them, producing them, and they're buying them. And HAL is also, I think, as far as my website information goes, HAL is trying to build a unmanned helicopter and things like that. And I see a very big market for drones and things like that. These
Yes,
are going to be
thank you.
the future technologies.
Thank you, sir.
Yeah.
So I think most of the questions are already been covered, and as both of the speaker have mentioned, we'll share their contact details with the audience.
Yeah.
We'll
Yeah.
share their contact details, and
Yeah.
if you have any specific questions, then you can directly contact them, or you can contact through us. Yes, sir. Yes, sir.
I think, Dr. Joshi, it is better directly we give the contact details of speakers. They can contact. That is easier.
Yes, sir. Yes, sir. Yes, sir.
Yeah, please.
Yeah. I think
So
we'll also keep the institution in the picture on our interactions, and then
yes, sir.
yeah.
Now, better
So
to give our mail IDs so
yes,
that
yes. We'll
institution
share
also
your
will
email
be in the
IDs.
loop.
Yes, 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 sir.
Yeah.
Okay. Thank you, both of you, sir. With the permission of Honorable Vice Chancellor, sir, now may I move towards the conclusion, sir?
Please.
Yes,
Go
sir.
ahead.
Thank you, sir. Thank you, sir. So I thank both of you for your valuable time and your guidance on this occasion, on the second session of this Friday lecture series under Atmanirbhar Bharat cell. At the beginning, there were some issues related to the technical problems. I apologize for that. Initially, there was a problem with the YouTube streaming as well. But afterwards, the YouTube streaming was also done, and we have with us the recording of the whole program. So we will upload that recording through our YouTube channel, so that whole program the people will be able to see it later. Now it is time to give the vote of thanks for formal vote of thanks for this particular program. First of all, I am very much thankful to our Honorable Vice Chancellor, sir, for his continuous encouragement and support for conducting this type of program and bringing such eminent personalities to address us and with a very focused and theme-based areas, because both these areas, like entrepreneurship is the backbone for the Atmanirbhar Bharat. At the same time, aeronautics is an area which is something which in general the notion is probably we are importing everything from outside. So this is actually eye-opening for most of us. So both the areas were very interesting, and I thank our Honorable Vice Chancellor, sir, for bringing such type of speakers on this occasion. And
Thank you,
I simply
Joshi.
salute, I simply salute, sir, your zeal towards this program, because even though you were traveling, still we were actually at the ground, but still we were actually not able to connect, but you were connected.
I'm just
Simply thank you.
entering my house.
Yes, sir. Yes, sir. We
Whatever.
simply salute your zeal about this program, sir.
Thank you, Dr. Joshi.
Thank you, sir. So I also thank our both the speakers who are actually from the field. Mr. Sham Sundar, he has worked into this aeronautic industry in HAL, and it will be very interesting for all the audience to know that he was the person who was actually involved into the Dhruv helicopter, which he had shown during his presentation. He was involved from the drawing to the final design, and then prototyping of that particular helicopter, and then the final production of that helicopter. He has also involved into building the trainer simulator for the pilot, and he has been involved in this aeronautical industry since mid 70s. So a vast experience he has into this, and then he has really opened the insight of this particular industry to all of us. So I, on behalf of the university and the Atmanirbhar Bharat Cell, I thank you very thank you, Shamsundar sir. I thank Mr. Balkrishna, who was also who is also a person who is very authentic in the area of entrepreneurship. And while before the sessions also, whatever calls I had with him, I could sense his interest and his feeling that how these youngsters can come into the entrepreneurship. So that is what his mission is. So he has actually started his own industry in 1997, and right now more than 110 employees are there in his industry. He had already a experience of around 15 years, and then he entered into the entrepreneurship. So both sides he has seen, the service as well as the entrepreneurship, both he has seen. And from his presentation also, it was actually very informative and very practical tips and practical things he has given in his presentation. So I thank Balkrishna sir for your wonderful presentation, and I expect both of you, we will have some more knowledge and information from you in some further different programs as well. Thank you, both of you. Then I would like to thank the Executive Council members and the Academic Council members, and especially Professor Jagtap, who always takes interest and makes it a point to attend the program and then active participation during the program. So today also he has, with his questions, he has added some more knowledge to these sessions. So I am thankful to all the respected Executive Council members and Academic Council members. I'm thankful for all the principals of affiliated institutes and faculty of D.Batu Lonere and from the affiliated colleges as well. So they have spread this amongst the student as well as amongst the faculty and staff members at various colleges. As a result of that, even though we had at the beginning some problem with the YouTube live, and I was actually skeptical when the live will start, whether the audience is still waiting or not, but I was really surprised to see that still we had a very good viewership, and then a lot of audience was there waiting for the program to start. And I really thank all the principals.
Thank you.
Shastri sir, anything has to be added?
Yeah, I just have, I on my personal, no, just one point.
Yes, sir.
On my personal behalf, I would like to thank both the speakers for having obliged my request and gracing this occasion. I think we will have next week a panel discussion wherein I would like to request Professor Jagtap Saab to kindly coordinate this panel discussion with three experts we are going to have on entrepreneurship again, sir.
That's great. That's great.
Yeah. Next week, same time, Friday evening, 5 o'clock onwards, three speakers will be there. And then I would be requesting you to kindly
Oh, sure.
coordinate.
I'll certainly join.
Yes, sir. This is the message I would like to give to all our guests, participants, and then those viewers watching this program through YouTube. Next week, another very lively and vibrant session we are going to have with three more speakers. Thank you very much, sir.
Thank you, sir.
Thanks a lot.
Thank you, sir.
Welcome, sir. Welcome.
Thank you, sir. Thank you.
Welcome, sir.
Thank you, sir. I will switch off.
Welcome, sir.
Yeah.
Welcome. Yeah.
Thank you, sir.